Good morning, everybody. Happy Tuesday. Jumping into another lesson today, and we're wrapping up this unit. Actually, we have today and tomorrow would be new lessons, and then Thursday is going to be a review day for this unit, and then we're actually done functions and relations, and we will be writing that summative assessment, which is kind of the unit exam. You can start it as early as Thursday. So looking ahead, we've got lesson today, lesson tomorrow, and then Thursday's review, and that's when I'm going to release the exam as well. Friday is a staff PD day where we're going to do some online development. And so we won't be putting out new materials on Friday. So with that in mind, I'll just give you that summative assessment Thursday. You can do it on Friday, right? You're not going to have anything else to do that day. You can do it over the weekend. You can do it over holiday Monday. And then it's going to be due that night. And then we'll start up our next unit on Tuesday. So with that said, let's jump into this lesson on function notation and check another one off the list. Here we are, page 465, jumping into a lesson on function notation. And really all this is, another way to describe a relation or another way to describe how things work. So, like we have graphs, we have table of values, arrow diagram, ordered pairs, mapping. We have all of these different ways to represent a relation, and this is just another one, okay? So mapping notation we looked at yesterday, that was this, where it said a function, x becomes y. X turns into this, right? So the example they have is x turns into 2x plus 3. So if I was given an x, I would multiply it by 2 and then add 3, and then I have the other side. Okay, so that's with a function. We can have the mapping notation. And then today you're going to see function notation is very similar to that. So just a little terminology. You won't see this often, but maybe it's important to know. For a function, for that example given, okay, the image of 5 is 13. So it's like I plug in 5 and the image I get on the other side is 13. Or another way to say that is when x equals 5, the value of the function is 13. So you won't see that often, but just maybe important to notice that image word. Okay. Here's function notation. Okay. We, instead of saying x becomes this or x becomes this, we use what we call f of x, and it looks like this. Okay. F bracket x bracket. Okay. And that's it. It's really no different. Here is that same function written in function notation. That's read f of x. Well, if I forgot about this whole function thing, to me that looks exactly like y equals 2x plus 3, where I've got x as my input, y is my output. Well, here f of x is my output. And that's function notation. All it is giving y a new name. Instead of calling it y, I call it f of x. It's just renaming your output. And really, just like any name that you give, sometimes it'll have a name that has a lot of specific meaning, based on the context. Other times it's just f of x, g of x, h of x. We just pick a letter of x. And all that is, this is one block, f of x. That means the output of the function. It's like replacing y. So if I look at these three examples side by side, I could write the same relation or the same function using mapping notation. X becomes 2x plus 3. So 5 would become 2 times 5 plus 3, or 5 would become 13. That's mapping notation. Okay. If I replace the x with a 5, I replace the x with a 5 further on. Function notation, this is the new one. If I have f of x equals 2x plus 3, it's still this idea of 2x plus 3. Well, I plug in my 5. Notice it used to be f of x. Now it's f of 5. So wherever I saw an x, I now replace with a 5. Plug it in. Yeah, you get f of 5 is 13. Or just a classic y equals. Plug in a value of x of 5, and you get 13. So it's the same thing. It's just maybe different ways to represent it, different ways to write it. Okay. F of x. This symbol can be f at x or f of x. I'll say both. They mean the same thing, f of x or f of x. And just a comment below, it's not multiplying. It's not f times x. It's one thing, f of x altogether. It's the name of the function, or it's a way for us to describe the function. So keep that in mind. All right, well, let's use function notation. Okay, it says, consider the function f of x equals x squared plus 5. And then I have another function, g of x equals 4 minus x. Evaluate. Well, this is where the name of the function gets convenient. I am looking for a, f of 3. Well, if I'm dealing with f of 3, I know I'm dealing with f of x. I'm dealing with the f function. For b, I'm dealing with g of 1, so I know I'm dealing with the g function. F of 3 would equal, okay, well, I know f of x was equal to x squared plus 5. And what I wanted to get in the habit of is, okay, well, it was f of x, but then I replaced that little bracket with a 3. So wherever there was an x, now I'm going to put a 3. So instead of x squared, I'm going to put 3 squared. And anything I sub in, I put in brackets. Then I can say f of 3 equals 9 plus 5, or f of 3 equals 14. So it's just another way to substitute into equation. It's another way to see. And it's, pretty common moving forward, function notation. So it's worth getting used to. Okay, g of 1. Well, g of x, I'll write that above just for the example, is 4 minus x. So g of 1, the x got replaced by a 1. So wherever I see an x, I replace it with a 1. And then I can evaluate. 4 minus 1 would be 3. G of 1 equals 3. Done. Okay, that's it. That's just evaluating. That's all we have to look at. So C and D, I want you to try ahead of me. E, just very quickly, it's saying find f of 0, find g of 0, and then subtract them. So I have to find this first, then I have to find that, and then I can subtract my answers. So all three, try those ahead of me. Pause the video and try ahead of me.
A few moments later.
All right, so I've gone ahead and done a few of these ahead of you. C, f of negative 2. Well, that's the f function, so I'm plugging into x squared plus 5. Make sure I plug it in with brackets. It's negative 2 squared, which gives me a positive 4, plus 5, you get an answer of 9. Okay, g at negative 2, 4 subtract negative 2, well, that would be positive 6. Subtract the negatives just like adding. And then I get to E, and this is one I kind of alluded to, and I'll kind of do it with you. If I have the two functions within this, it's saying first find f of 0, find that value, then find g of 0, find that value, and then subtract. So if I wanted to show that BEDMAS-wise, I'd just put both of those in brackets. Okay, so I'm finding f, I'm using the f function over here, and then I'm finding g, I'm finding the g function over here, and I'll go ahead and evaluate. Okay, so 0 squared plus 5, well, 0 plus 5, that's just 5. Okay, minus 4 minus 0, well, that's just 4, for an answer of 1. There you go. Okay, so I can do, multiple things with this, just making sure I'm plugging into the appropriate function when I need to. All right, let's go on. Okay, consider the function f defined by f of x equals f 5x cubed minus 2x, x element of the real. So all that's saying is, hey, this function, you can plug in any x you want. Okay, any x is going to be fine with this function. Then it says determine all of these things. Okay, well, f of negative 3. Okay, I plug that in. And I'm going to get, okay, wherever there was an x, it was f of x, now it's a negative 3. So wherever there was an x, I'm replacing with a negative 3. 5 times negative 3 cubed minus 2 times negative 3. 5, negative 3 cubed minus 2 times negative 3. So whatever went in that bracket then replaces the x. Okay. So that would be 5 times negative 3 cubed. Negative 3 times negative 3 times negative 3 is negative 27. Minus 2 times negative 3. Well, negative 2 times negative 3, that would be actually a positive, so plus 6. Okay, running out of space. 5 times negative 27. Let's find that. 5 times 27 is 135. And it would be negative. Plus 6. And running out of room. Equals negative 135 plus 6 would be negative 129. Okay, so it doesn't matter how big the numbers are or how complicated the function is. I'm just evaluating. Okay, I'm just evaluating like normal. Next one, the value of f when x equals 2. Well, that's asking for f of 2. You know, it kind of phrases it differently, but it's asking you, hey, plug in an x value of 2. So I'm plugging in here, here, and here. And I'm going to find that. 5 times 2 cubed minus 2 times 2. That would be 5 times 8. 2 cubed is 8. Minus 4. Or that would be 5 times 8 is 40. Minus 4, which is 36. Awesome. I can evaluate there. And then it starts to get a little bit different, and maybe I start using different words as the image of 7 under f. So this is, I think I talked about at the very start of this lesson, the image of 7. So that's saying, hey, if x equals 7, what is the value of the function? Okay, when you plug in 7 into this function, what do you get? So yeah, this is just saying plug in f of 7. It would be 5 times 7 cubed minus 2 times 7. F of 7 equals 5 times, I want to say 243. 7 to the power of 3. 343. That's too bad. 5 times 343 minus 14. F of 7 equals 5 times 343 is 1,715. Take away 14. Your answer, f of 7 equals 1,701. There you go. So again, that's just maybe with a bigger function, maybe with some bigger numbers, but yeah, I can still find the value of the function. It's like, here's x, find y, right? Plug in this value of x, see what you get for y. We've been doing that for a long time. Okay. E and F. Okay. This takes it a little bit further. It's definitely a bit of an extension, but I want to get us thinking about this idea of, if I have a function, whatever I put in that bracket is going to replace, okay, what was pre-existing. So here's f of x. It equals 5x cubed minus 2x. They want me to talk about f of a. So what I'm looking at is it used to be an x, now it's an a. Wherever there was an x, now gets replaced with an a. So it'll be 5a cubed minus 2a. And I can kind of simplify that. I don't need the brackets on the a's, right? It's just a variable, so that would be good. So I can replace not just with numbers, but also with variables. And this goes somewhere down the road. This is more of a 2030 thing, okay? So replacing letter for letter straight up, that's pretty easy. The x's became a's, okay? I can also modify within. So f of 2x is what we're going to look at. Let's start by looking at f of x, okay? Equals 5x cubed minus 2x. And what I want to replace that with is f of 2x. So keep the same thing in mind. Wherever there was that original x, now you're going to plug in a 2x. So 5 times x cubed, well, no, now it would be 2x cubed. Minus 2 times x, well, no, now that x is 2x. So the function notation is replacing whatever I had in there. Okay. Well, let's see if I simplify that out. 5 times 2x cubed would be 5 times 8x cubed if I actually cubed that, minus 4x. And I can simplify that a little bit further. Okay. 40x cubed minus 4x. Okay, so that's a stretch. I am not going to ask you to do that at the 10C level. Okay, I will only ever ask you to deal with function notation with numbers. But eventually it can be worked where I start actually plugging in different expressions within there. And the reason for that is this actually will tell us things about the graph. So this will allow us to transform a graph and talk about a graph and things like that. That's the reason. That's where it goes. So the stuff in blue, yeah, I'll ask you to do. The stuff in purple, that's interesting to look at, but I won't ask you to do it this year. Okay. Question 3, yeah, great question. I would not ask you to do that this year. I'll do it just for interest's sake. It says here's p of x. Here's the function. 4x squared minus 6x plus 1. Determine a simplified expression for p of x minus 3. Okay. Same idea, except now I'm dealing with a binomial. Okay, so I'll deal with this one quickly. Wherever there was an x, and now replace with x minus 3. X minus 3 squared minus 6x minus 3 plus 1. Okay. And now it's my job to simplify this thing. So I'd have to square x minus 3 times x minus 3 is x squared minus 6x plus 9 minus 6x plus 18 plus 1. I'm doing the distributive property there. So I'm rattling this off quickly. You don't have to do this one. I just maybe show it for people that are interested. This is a really complicated example. This is a 20-1 level. Okay, distributive property, 4x squared minus 24x plus 36 minus 6x plus 18 plus 1. All right, let's finish it off. 4x squared minus 30x plus 36 plus 18 plus 1. 18 plus 1. 55. Okay, there you go. That's the expression. So, I can really do this with anything. I can take this function notation and whatever I'm subbing into the f of x subs into the rest of the question. But like I said, only worry about what I did in blue. Don't worry about this purple stuff. Okay. All right. Last question. A couple more. Okay. Consider this function f of x equals 10x minus 3 for any x. Okay. Determine the value of f of x if f of x equals 47, or I'll also do f of x equals negative 23. Well, let's go back for a second. The examples that we've been doing, I've been giving you the x value. I've been giving you the number inside of the brackets, okay? Or I've been giving you the input. What this is, that's the output. If f of x equals 47, that's like saying y equals 47. So instead of plugging in just the x, now I'm replacing, instead of f of x equals 10x minus 3, what I'd say is 47 equals 10x minus 3. So just like at the start of this unit, maybe I give you the y value and you plug that in for y and solve. Maybe I give you the x value and you plug that in for x and solve. Whatever value I give you, you plug in the appropriate spot. So I didn't give you x. I'm asking for x. And I gave you the y piece. I gave you the full f of x. So I'd have to solve algebraically. I would add 3 to both sides. 50 equals 10x. Divide by 10. And divide by 10. 5 is equal to x. There we go. Showed my work on the side, but there you go. There's your answer. X is equal to 5. So this is the other side of function notation. Maybe I give you the x value, or maybe like these ones, I give you the y value, the f of x. Okay. Why don't you pause and do B ahead of me?
1 hour later.
Okay, hopefully you had a chance to do it ahead of me. I've got it started. F of x equals 10x minus 3. It gave me the f of x value. So instead of writing f of x, I'm going to write negative 23. And now I'll solve. Add 3 to both sides. negative 20 equals 10x. Divide by 10, divide by 10. So you get an answer of negative 2 equals x. Okay, and maybe I'll write it up there. There you go. Okay, so maybe I give you the x. Maybe I give you the f of x, knowing the difference in what to plug in. All right, last question. Okay, it says, consider this function f of x equals x squared minus 5. Okay, great. Evaluate f of 4. And then B says solve the equation f of x equals 4. This is the perfect example because this gives me both sides. The first one, f of 4, wherever there was an x, I now replace with 4. This would be 4 squared minus 5. Okay, f of 4 equals 16 minus 5. F of 4 equals 11. That's like I gave you the x value. Okay. B, solve the equation f of x equals 4. Well, here's where now I'm writing, and I'll write the equation, f of x equals x squared minus 5. Instead of writing f of x, I'm going to write 4. And now I have this. Okay. And now I'll solve. I'll say you would add 5 to both sides. You get 9. 9 equals x squared. Now we're going to solve this. The opposite of squared would be to square root. And here's where I'd tell you to be careful, because if I introduce my own square root, you're saying, what? Squared gives you 9? Well, there's actually two possibilities. It could be the positive or negative version. Move my work up here. X equals plus or minus 3. Or another way to say that is x equals 3 or x equals negative 3. Okay, we've seen that a couple times. If I'm introducing my own square root, I have to keep in mind, yeah, there are actually two things that satisfy this equation. Could be the positive version, could be the negative version. Okay, so that's the difference. Here it gave me y and I solved. Here it gave me x and I just plugged in. Okay, C, solve the equation f of t equals 75, where t is greater than 0. Well, there's a couple things going on. If I look at the original f of x, it said x was an element of the real. Okay, x could be anything. Now I'm talking about f of t. So all we did is instead of x squared minus 5, it's t squared minus 5. And I'm going to take a guess, right? Sometimes I said the name will have meaning. T usually represents time, and time always has to be bigger than 0. So to me, I think this function's probably talking about time now. Then it says, okay, we'll consider this and now solve for f of t equals 75. So I plug in a 75 equals t squared minus 5, and I'm going to go through and solve. Add 5 to both sides. Add 5 to both sides. I get 80 equals t squared. And here's where I'm going to solve. I'm going to do the same thing. I'm going to take the square root. Okay. And I might be tempted to say, oh, I introduced my own square root. It better be the plus minus, right? T equals plus or minus the square root of 80. Except, based on this function, t has to be bigger than 0. So I don't actually have two options based on the restriction they stated. This is like when we have a real context and we say, no, it's time. Okay, it's not the plus or minus. It's just the square root of 80. Okay, it can't be anything. It's just that. So there's my answer. Move my work up here. I have to simplify that. I think this goes back a couple of units before we were even online. 80 is the product of, and I'm trying to think, something that would multiply to 80, but it needs to be a perfect square. So maybe I think 4 multiplied by 20. But that's a pretty small perfect square. So you think, is there a bigger one? And I think there is. I think 16 times 5. Let's check. Yeah, 16 times 5 equals 80. So what that allows me to do is I can take the square root of 16. It's 4. Can't take the square root of 5. And that would be my exact answer. it said answer in simplest radical form, so I won't go to a decimal. Okay, so that last example, just, a little restriction on it, but ultimately I'm doing the same thing. So there you go. For the most part, these are the two things I'm asking you to do. Here's a function. Here's the x value. Tell me the answer or tell me the y. And then the opposite. Hey, here's a function. Here's the y value. Tell me the x. Here's the output. Tell me the input. So a little homework for you. 467, 2, 3, 5, and 8. And that is it for today. Thanks for watching. Well, there you have it. That is another one done for us. Function notation. We're going to spend a little bit more time tomorrow talking about function notation and some other things within the unit. And then that's it. So we're pretty much done with the new content. So for today, get your homework done. Send me some questions in the forums. Let me know if you're having any issues. Get your late assignments done, all of that. And get ready because we're starting that summative assignment. That'll be out tomorrow. You'll have some review, and then you'll be able to start on that assignment. Smash the like button. Hit subscribe. Boom, boom, boom. That's it. Have a fantastic day, everyone.